Hello everyone, welcome to our 48-volt BMS system solution demo. In this demo, we are going to show you how with using our 4th generation LTC6812 IC, we have realized a 48-volt BMS system. So this is how we have done it. Basically this LTC6812 is a 15-channel part and 6813 is a 18-channel part. And this along with an external 2944 is being used to do the current sense measurement, and then we basically have it connected to the MCU, which is in this case we use the SDPK1 board as the MCU, and then we have basically the FET drivers being controlled by the LTC7000s, so which are high side gate drivers. Now there are multiple solutions, systems architecture possible in this, where customers may decide no, they will not use 2944, or they will decide to use a different current sense connected to 6812 on the GPIO lines, but all those things can be realized with this solution. Coming to our demo, basically, so what this demo is basically a 48-volt 2.5 kilowatt system that can be used to realize a 2.5 kilowatt system, and the input power source could be the lithium or any lithium-ion chemistries, or we could also look at, for example, a voltage range. So the voltage range supported on this part is from 15 volt to 54 volt. Current, it could be 50 amps continuous or 65 amp peak current. 15 to 18 cells can be connected. At the cell level, we have the over voltage, under voltage, and the over temperature, under temperature control on the software side. On the back level, we have the overcurrent, short circuit current, over voltage protections that are there already in the system. We can balance up to 200 milliamps per cell here. So 6812 can supports us to up to 200 milliamp. On 6830 you can go up to 300 milliamps. And the gauging is via microcontroller. The communication is via SPI. And the wake up is electrically initiated, so we don't have we kind of can either supply through a 15 volt supply externally, which converts the DC down to the microcontroller supply, or you could also use a USB to power up the system. And the operating temperature for the entire system is around minus 40 to 125. And then the main features that we are covering from this reference, right, is voltage measurement, current measurement, temperature, protection mechanism, cell balancing, the BMS interface with the microcontroller software, the reference algorithms that are covered. So this is all which is already done. The CAN interface with the CAN DBC file is in development process, but that is more of a definition of the packets putting in the format, but we already know what type of packets we would be required to do. Okay, so this is a full demo system that we typically use to demonstrate our system. So this is a cell simulator board, which can basically be connected with 18650 cells, and it can be directly basically you can connect 15 or 18 cells, and you can chart the other ones. So as you see in the picture, there are 15 cells connected. You have a battery connector which goes to your reference design board, and then you have the load and the connector. So the additional connector that you see is basically the NTC connectors. So the temperature connector which are sitting on, which can monitor the cell temperatures. And then you would have an MCU board which is basically mounted below this. So you don't see that, it's a SDPK1 board. And then you, for the load side, we have like a DC-DC and a motor that can be used to realize that. Okay, so I think, and just one more thing is that on the software, on the MCU, there are 3 layers of software that are running. Basically, the HAL layer, the middleware, and the application code, which are used to realize the full system. Okay. So let's, without any more delays, let's get started on the demo.